So as we move into chapter 3, section 2, we get into what's called factoring special products. The first type of special product we're going to come across is described as the difference of squares. So it has a nice little pattern here. If you have this a squared minus b squared, it's going to factor into this a minus b times a plus b. So remember, special products, notice how if I have x minus 3 times x plus 3, if I use FOIL and bring that into play, FOIL would say multiply the first together. In other words, multiply the x through both pieces. O is the outer two pieces. So if I do that to start with, x times x is x squared. X times 3x is a positive 3x. And then the remaining part of FOIL, so we do the inner. So the negative 3 has to go through both pieces. So negative 3 times the x is the inner, and the negative 3 times the positive 3 are the less. So we have to distribute the negative 3 through the second two terms as well. So when we do this, negative 3 times 3x gives me this negative 3x. And then negative 3 times 9 would give me negative 9. Now, what's interesting when you have basically the same terms, but one's negative and one's positive, notice that the inner terms actually cancel out there. So the two inner terms actually cancel out. So we end up with then just this x squared minus this 9. So what I pick up on then is x squared minus 9 is the same thing as x minus 3 times x plus 3. But notice how this is described as the factored form. Because remember, we're trying to break it back apart. So what I pick up on is if we have a squared minus b squared, in other words, we have two terms, and the first term can be written as a perfect square, and the second term can be written as a perfect square, and we're subtracting them, then all we have to really do is pick up on what was squared, and then we subtract what was squared, and then again we go what was squared, and we add what was squared. So what I mean by that is if we look at this 4d squared minus 25, what squared would give me 4d squared? Well, what squared gives you a 4 would be a 2. What squared gives you a d squared would just simply be a d. So let's say 2d squared is the same thing as 4d squared. So notice how the 2d becomes my a in my formula. And then if we look at the second part, notice that what squared gives me 25 would be a 5. 5 squared is 25. So notice how this actually fits the model of a squared minus b squared, where the a is the 2d and the b is the 5. So if I follow that through, then this turns into then we have our two sets of parentheses. We have 2d minus 5 in parentheses, and then we just rewrite that again, 2d plus 5. And that saves us the trouble of working harder. This makes us work easier by recognizing the pattern. So we have that special product of a difference of squares. So again, if I did another example, 16 squared, I'm sorry, let's try that again. 16y squared minus 49. Notice that this is a difference of squares because what squared gives you 16y squared would be 4y squared. I keep getting ahead of myself there. So 4y squared, 4y times 4y would be the same thing as 16y squared. So that first term is a perfect square because I can raise this 4y to a power of 2. That's what I mean by perfect square. And then what can you square and get a 49? Well, if we know our math facts, we know that 7 squared is this 49. So what this tells me is I can use this formula. If a squared minus b squared holds true, then we can factor this as a minus b and a plus b. So notice that the 4y becomes my a, 4y minus the 7. Then we just rewrite that again, 4y plus the 7. So it becomes a very easy uh, expression to factor. So we call that the difference of squares strategy.